sorry about that. So I just drew on this diagram here. Basically what I mentioned in the question is move at 40 meters per second at an angle of 60 degrees to the horizontal. On the right side I drew the motion of the ball we expect to see, and here this triangle that has the u next to it, the horizontal, the hypotenuse, that u is the magnitude of the velocity, right? On this side we have the vertical component of the velocity, so we could write that as uy. On this side we have the horizontal of the component of the velocity, so we have ux. So and this angle here we can write that as theta, right? That is equal to 60 degrees. So in this case we have sine theta is equal to the opposite over the hypotenuse, which is equal to uy over u. Therefore we have uy is equal to u times sine theta. We also see that cos of theta is equal to the adjacent over the hypotenuse, which is equal to ux over u. Therefore we see that ux is equal to u cos theta. Right, so now we could substitute the values into the equation, right? In this case uy would be equal to 40 sine 60, ux would be 40 cos 60, right? And then you'll get the values for uy and ux. Now that is just initially separating it into the components. Now we had the equations of motions. We saw v is equal to v is equal to u plus at, s is equal to ut plus a half at squared, v squared equal u squared plus 2as, right? Now these equations of motion can be applied to the horizontal component independently and the vertical component independently, right? Now for the horizontal component, a is equal to 0, right? There's no force acting horizontally on the ball. We are ignoring wind, right? As seen in the question, and this is for the horizontal component, which you mean the equations I just wrote. V is ut, u plus at, s is ut plus a half at squared, etc. Oh, ux is equal to u cos theta. Yeah, so that one is horizontal and uy is vertical. So if we look at the diagram here, this angle here, theta, in the triangle that doesn't have the box, that angle theta is equal to the same initial angle of 60 degrees, right? So horizontally we have ux along that that triangle, and vertically we have uy, so uy would be the vertical velocity. So knowing this now, we can separate them into we can use these separate components in separate equations of motion, one for the vertical components and one for the horizontal components. So I wrote these equations of motion down here. So in the horizontal component, there is no forces acting on the ball, right? Ignoring air resistance. So therefore, if there are no forces acting on the ball, the acceleration on the ball is equal to 0. Now in the vertical component, there is the weight acting downwards on the ball, right? So if we take up to be positive and down to be negative, the weight is acting downwards. Therefore, there would be an acceleration on the ball, which is the acceleration due to gravity, and that is acting downwards. So the value of the acceleration would be equal to negative g. Right? So when we are using these equations, we substitute a is equal to 0 and for the horizontal components. So we would see horizontally what we would see is Vx is equal to Ux plus 0t, which is just equal to 0. So basically the initial velocity in this is x, right? The initial velocity horizontally is equal to the final velocity horizontally, which is what we expect because there's no forces acting on the ball to cause it to speed up or slow down. That is basically like Newton's first law of motion, right? A ball, an object will continue with constant velocity unless acted upon by an external force. In this case, there are no forces acting horizontally, so it continues with the same horizontal velocity. We also see that Sx is equal to Ux multiplied by t, right? Because a is equal to 0. And this is just the usual formula. Distance is equal to speed by time, right? Now vertically, things are a little bit more complicated, right? Then we will have now Vy is equal to Uy plus now a is negative g, so this would be minus gt. We would have sy is equal to Uy t minus a half gt squared. We would have Vy squared is equal to Uy squared plus minus 2gs. Now, something that could be asked is to determine the maximum height of the ball, right? Now, at the maximum height of the ball, the vertical component of the velocity is equal to 0, right? Because at the maximum position, it just stops going upwards and it just is going to start going downwards, right? Therefore, we can use these equations here and rearrange it where Vy would be equal to 0, because at that point the velocity is equal to 0. So we can use the third equation, right? In the third equation, Vy would be equal to 0. So 0 is equal to Uy squared minus 2gs. So the maximum height, this should be SY, right? So the maximum height would be SY. We can write this as 2GSY is equal to UY squared. This is our Y here. So SY is equal to UY square over 2G. Right? And we can just substitute that our values for that from above here, right? We had the vertical component is u sine theta. So this is just equal to u squared sine squared theta over 2g. And we could substitute those values and get the answers. Like for example, in this question, u was equal to 40 and theta is equal to 60. So if you just substitute 40, 60 and g 9.81 or 10, depending on what the question gives, you will get the answer for that. Now, something else that could be asked is the time of the flight, right? So basically, how long does it take to go from one end to the other end? So what we could do is we can utilize the symmetry of this problem, right, of this case. So it would take the same time to go from the initial vertical point to the maximum height as it takes to go from the maximum height back to the ground, right? Because if we look at this diagram, it is symmetric, right? So it would take, because the velocity, the horizontal velocity is the same throughout the motion, the horizontal velocity does not change. It takes the same time to go from the starting point to the middle as it takes to go from the middle, the point of maximum height, to the end, right? So we can utilize that and we can say that time of flight is just basically 2 times the amount of time it takes to reach maximum height. So the time taken to reach the maximum height, we can find that using the first equation, right? In the first equation, we would have so before I write the time of flight, let me write time to reach maximum height. So in the first equation, we would have Vy is equal to Uy minus Gt. Now at the maximum position, the vertical component of the velocity is equal to 0. So Vy would be equal to 0. So in this case, we would have 0 is equal to Uy minus Gt squared, right? So therefore, now Uy is equal to Gt squared. Therefore, Uy over G is equal to T squared. Sorry, I don't know why I write in square. There's no square here. Right? There's no square in this first equation. Vy is equal to Uy minus Gt. Now, so we know Uy from above here. Vertical, Uy is equal to u sine theta. So we could write this as T is equal to U sine theta over G. And the time to reach the maximum height now is just twice this. Sorry, the time taken for the full flight is equal to twice this, which would be equal to 2U sine theta divided by G. Now, if we want to find the distance from the total distance covered, the total horizontal distance covered, we have to use one of these horizontal equations, right? So we'd have to use the second equation because that's the only one with distance. So Sx is equal to Ux multiplied by T, right? Now in this case, we would have to use T as the time of the flight, right? So is equal to Sx, the equation is Sx is equal to Ux times T. Now in this case, T is 2 times U times sine theta over G, right? And we know Ux from above, from here, the horizontal component Ux is equal to U times cos theta. So we can write that here, U cos theta times 2 U sine theta over G is equal to the horizontal range, right? So we could put the U's in front, we could put the 2 in front, and U times U is U squared, and we get this. Now you could just substitute your values into this equation and you will get the answer, right? So we had U would be 40 meters per second. Theta we had is 60 degrees, I think. Yes. So theta is 60 degrees, U is 40 meters per second. So we could substitute those values into here and, well, G, and we would get the answer for the horizontal range, right? But in general, there's a trigonometric function which I do not expect you to know. So you do not need to know this function, this identity we call it, that can relate to cos theta sine theta. So we could also write this as U squared sine 2 theta over G, right? So in the notes you would see it written as this. This is because of our identity, which is sine of 2 theta is equal to 2 sine theta cos theta, right? So when you're doing maths, trigonometry, you would see this. So this is why in the notes we have it written as the final value there. You would need to know how to separate the components into the velocity into vertical and horizontal components in terms of actually using like this formula or this formula, or well, even this or this, I wouldn't really expect you to use these formulas. But you need to know what we did at the start here, which is to separate them into the horizontal and vertical components, and also to be able to apply, to know that the horizontal velocity is equal to 0. Sorry, not the velocity. The horizontal acceleration is equal to 0, and the vertical acceleration is equal to negative g. Any more questions you all had, or should we do the past paper? Okay, so let's move on to question 2. Right, so in this question 2, we had the laws of, the first part of question 2 was to list the laws of reflection, right? So the two laws of reflection, the angle of incidence is equal to the angle of reflection, and the reflected ray, the incident ray, and the normal to the plane, and the normal all lie on the same plane. So those are the two laws of reflection. The second part was to distinguish between specular and diffuse reflection, right? So specular reflection is normal reflection where all of the reflected rays are parallel to each other. Diffuse reflection is random scattering, right? So because of the uneven surface of the reflecting medium, some rays of light would be reflected at different angles to other rays of light. So the reflected rays are no longer parallel, even though the incident ray was parallel. So an example of specular reflection is like a mirror. An example of diffuse reflection is like reflection of a wall or of a piece of paper or something like that. State Snell's law in equation form defining all variables. So Snell's law, we know n1 sine theta 1 is equal to n2 sine theta 2, where defining all variables is just easiest to draw it out, right? So this is the normal, this is theta 1, this is theta 2, and 1 is the refractive index, and n2 is the refractive index of this one. Right, so we could say theta 1 angle of incidence, and theta 2 is angle of refraction. It's not necessary to draw the diagram, but if you have the diagram and you don't have theta 1 and theta 2, you'd still get the mark, right? The next question, list two necessary conditions to obtain total internal reflection. So these conditions would be that the ray of light has to be traveling from the medium with higher refractive index to the medium with lower refractive index, and the angle of incidence has to be greater than the critical angle. Right, so that was part A of the paper. Of question 2, sorry. Part B now. A ray of light travels from a vacuum to a transparent eyeglass with a refractive index of 1.5. What changes occur in the frequency of light, if any? So when refraction occurs, there is a change in wavelength because the velocity of light changes in the medium with the higher refractive index, but the frequency remains the same. That is because the color remains the same, right? So the frequency does not change. The number of wavefronts passing per second remains constant. The second part of this question, calculate the speed of light in the eyeglass. So we know that N is equal to C over V, right? Where V is the velocity of light in the eyeglass. So we need to find V is equal to C over N, which would be 3 by 10 to the 8 over 1.5, which would be 2 by 10 to the 8 meters per second. Part C. An object is situated 2 meters to the left of a thin bifocal lens of focal length 25 centimeters. Draw a ray diagram that includes the position of the object relative to the lens, the image position, the focal length of the lens, and the principal axis. So the first thing, let's draw the lens. Right? Then after, draw the principal axis. So the principal axis goes through this optical center of the lens, right? Now it's said that the focal length is 25 centimeters. So we could put here as the focal point and label this to be 25 centimeters. It said to draw the position of the object. So the object was situated 2 meters away from the lens. So now we write this to be 2 meters. The image position now. Now we haven't actually calculated the image position yet, but if we look at this diagram, we will see that the position of the object is further away from the focal point. Is further away from the lens than the focal length of the lens. So the focal length of the lens is 25 centimeters, but the object is located 2 meters away. So 8 times the distance as the focal length. Therefore, we know, since this is a biconvex lens, we will have a real image. Now the image, we know, would also be on the, because it's a real image, it would be located on the other side of the lens, right? So it would be located on the right side of the lens. And we know the image would be further away from the lens than the focal point. So the image, we know it would also be inverted, right? So we can draw the image to be here. Now we will find this distance in part 2 of the question. So in part 2, it says to calculate the image position. So to do that, we use the formula 1 over f is equal to 1 over u plus 1 over v. Now f is equal to 25 centimeters, which is 0.25 meters. Then we have u is 1 over 2. So 1 over v would be equal to 1 over 0.25 minus 1 over 2. This would be equal to 4 minus 0.5, which is equal to 3.5. So v would be equal to 1 divided by 3.5. Right? Meters. And well, we could write this as a fraction, right? But just at least for the question, so because we're doing a lot of questions in a short time, I'll write it like this: 1 over 3.5 meters. Right? That's approximately 50 something centimeters. A little more than 50. Right. Now in part D, light traveling in air incidents on a glass block at an angle of 30 degrees to the normal. Calculate the angle of refraction in the glass block, which has a refractive index of 1.5. So we're basically going to use Snell's law, right? Degrees 1.5, right? Because air, as we know, we can assume the refractive index of air to be the same as that of vacuum. So we have n1 sine theta 1 is equal to n2 sine theta 2. So when we substitute n1 as 1, so we have sine of 30 is equal to 1.5 sine theta 2. So sine theta 2 is equal to sine 30 over 1.5. So theta 2 is equal to sine inverse of sine 30 over 1.5. I believe sine 30 is a half. Let me just clarify that. Yes, sine 30 is a half. So I could just write this as 0.5 over 1.5, which is equal to 1 over 3. So this is equal to sine inverse of 1/3, right? And well, you could substitute this into your calculator, and you would get the actual value. Right. So I created a playlist with all of the videos from 0501 and 0502. So I will send that to the class rep after this class, so you'll have access to all your recordings. Right. So that was question 2. Now question 3. What is the focal point of a lens? So the focal point of a lens is the point at which parallel light rays incident on the lens converge at, or the point at which, alright, let me say that back. The focal point of a converging lens is the point at which parallel light rays incident on the lens converge at. The focal point of a diverging lens is the point at which parallel light rays, after being incident on the lens, appear to come from. In the second part, describe how an image is formed in the human eye, including the functions of the cornea, pupil, ciliary muscle, and fovea. So we went through this already yesterday, I believe, but let's go through it again, right? So light is incident onto the human eye, and the cornea does most of the refraction because of its large refractive index relative to the air outside. The light then passes through the pupil that can change size depending on the intensity of light outside, right? So if it's very bright outside, the pupil becomes very small, so only enough light that is needed to have good vision would pass through the eye, right? Because if too much light comes into the eye, it can damage the light cells in the retina. And if the room is very dark, the pupil opens wide to allow more light into the eye, so you can see better at night time. Then after the light passes through the pupil, it passes through the cornea, then the aqueous humor, then the pupil. Then after, it's incident onto the lens. The lens that can change shape depending on the position of the object we are looking at. So if the object we are looking at is very far, the lens relaxes and it takes a thin shape so that it does not do much refraction. If the object we are looking at is very close, the ciliary muscles, they make the lens into a very curved shape, right? And in that curved shape, the lens does more refraction, so it allows the light to be focused on the retina. The retina is located at the back of the eye. The retina, it contains rods and cones. So these allow our these rods and cones, they convert the light into electrical signals which are sent through the optic nerve to our brain to process the image. The fovea is a high concentration of cones located at the center of the retina, at the back of the eye. So we have sharper vision at the position at which light is incident onto the fovea, right? So we concentrate, when we are looking, we concentrate on the object whose light is incident onto our fovea, and the rest of the vision is peripheral vision. Part B. A student reads an examination paper 30 centimeters from the lens of his eye. His retina is located 1.5 centimeters behind his lens. What is the required focal length and power of his eye to read the paper? So now you can use this formula. Same formula, 1 over f is equal, P is equal to 1 over f, which is equal to 1 over u plus 1 over v. Right? So this is equal to, the object is 30 centimeters. So 30 centimeters is equal to 0.3. The image is formed at his retina, right? So at his retina, that is located 1.5 centimeters behind his eye, so 0.015. So F would be equal to 1 over 0.3 plus 1 over 0.015, right? Now you could just substitute this into your calculator and you would get the answer in meters. Now the power is just equal to this value, and the power would be in diopters, right? So if you just substitute this into your calculator, you would get the value of the power and the focal length. Calculate the magnification. Now the formula we had for magnification is m is equal to negative v over u, right? Which would be equal to negative 1.5 over 30. Now because magnification has no units, we can leave v and u in centimeters and they cancel each other. So if I write centimeters here and centimeters here, they cancel each other. But previously, when we are finding power, when you are using that equation, it has to be in meters, right? So we had to convert it in meters to get the power in diopters. If you are unsure, just always convert to SI units, right? So if you are unsure, you could write this in SI units. So that would be negative 0.015 over 0.3. And you'll get the same answer, right? Determine the height of the words in the image on the retina if the letters are 3 millimeters high on the examination paper. So we know that m is equal to hi over h0, right? So we need to find hi. So hi would be equal to m times h0, which should be negative 1.5 over 30 times h0, which would be 3. Now, if we are writing the height of the image in millimeters, we can leave this as 3. So the unit here would be millimeters. So this now would just be equal, this cancels here. So this is 1.5 over 10, and we would get negative 0.15 millimeters. Right? Now in part 4, is the image real or virtual? Provide a brief explanation. So the image is a real image because it is located on the other side of the lens, right? So the object is in front of the eye, and the image is located on the retina, which is on the other side of the lens of his eye. So the image is a real image. We can also see that from the magnification, right? In the magnification, we have a negative value. So that negative value means that the that the image is a real image. The height, we see it has a negative value. So that means the image is inverted. Right? Oh well, actually the positive for the negative for the magnification, that means that the object is inverted, right? Right, so now let's move on to question 4. Briefly describe the location and movement of the positive and negative charges in a neutrally charged atom. So in a neutrally charged atom, there are an equal number of protons and electrons. So this is something you need to know for third semester as well, right? Like the models of the atom. So in the Bohr model of the atom, the positive charges are concentrated in a very small area, which in the center of the atom, which is called the nucleus. And negatively charged particles, which are called electrons, they orbit this nucleus, but they orbit the nucleus in specific energy levels. So we say these are quantized energy levels. So there is not a continuous range of energies that these electrons can have. They can only have specific values of energy. So we call these electron shells, and we say that these electron shells are quantized. State the difference between static and dynamic electricity. So static electricity occurs due to an imbalance of charges. So for example, if we have a positively charged rod and a negatively charged rod, we say that there is static electricity between the rods. Dynamic electricity occurs due to a flow of charges. So like for example, in the light bulb that we see lighting our room, electrons are flowing in the circuit and they flow through the light bulb, which produces the light. Now the question didn't ask for the example, I am just giving the example. Briefly describe triboelectric charging. So this occurs when two surfaces are rubbed against each other and there is a transfer of electrons from one surface to another surface. So for example, if I rub a glass rod against silk, the electrons from the glass, due to the rubbing, they are transferred to the silk. So the glass rod becomes positively charged and the silk becomes negatively charged. And part 4. List any two properties of electric field lines. So we know electric field lines, they start from positive charges, they end on negative charges. Electric field lines do not cross each other. The closer together electric field lines are, the stronger they are. Well, that was more than two properties, right? Determine the magnitude of the electric force acting on an electron located 3 by 10 to the negative 11 meters away from a nucleus consisting of 2 protons and 2 neutrons. So right, to do that we use the formula F is equal to Q1 Q2 over 4 pi epsilon naught r squared. Right, now we asked to find the magnitude of the electric force acting on the electron, right? So Q1 we would use as the charge of the electron, 1.6 by 10 to the negative 19, right? Then after, well, I don't really need the brackets. Then Q2 would be equal to the charge of the nucleus. So we are told the nucleus contains 2 protons and 2 neutrons. Now neutrons, as we know, they have no charge, right? So the charge of the nucleus is due to the 2 protons. And we know the electric charge of protons is the same as that of an electron, right? So you have 1.6 by 10 to the negative 19, but there are 2 protons, so we multiply it by 2. And then we divide by 4 pi times 8.85 by 10 to the negative, is it 11? 10 to the negative 12 times r squared, right, which is 3 by 10 to the negative 11 squared, right? And when you substitute this into your calculator, you will get a value. And that value would be in newtons, right? Because all of the units are SI units. Now, the question didn't ask, but this would be an attractive force, right? Because the nucleus is positively charged and the electron is negatively charged. In part C now, we have this circuit right. This is 100 ohms, 200 ohms, 300 ohms, and 12 volts, right? And they asked us to determine the equivalent resistance of the circuit given in figure 1. So the first part, what we need to do is find the equivalent resistance of these 2 resistors in parallel, right? So in parallel, I'm just going to write the equivalent resistors of those in parallel is equal to 1 over R1 plus 1 over R2, right, which is 1 over 200 plus 1 over 300. This is equal to 1 over 3 over 600 plus 2 over 600, which is equal to 1 over 5 over 600, which is equal to 600 over 5, which is equal to 120 ohms, right? Then now the total equivalent resistance is equal, so this, we could replace these 2 parallel resistors by a resistor of 120 ohms. And so the 100 ohms and this new 120 ohm resistor are in series with each other. So we can just write is equal to 100 plus 120, which is equal to 220 ohms. Right? So 220 ohms is the equivalent resistance of all these three resistors. In the second part of the question, calculate the current flowing in the 100 ohm resistor. So now we can use Ohm's law, right? So Ohm's law, V is equal to IR. We need to find I, so I is equal to V over R. So the voltage is given by the battery, which is 12, right? But the resistance we are using is not 100 ohms, right? Because now, if we look at the diagram, the current is not just flowing through 100 ohms, right? It's flowing through, we can replace this. Let's draw a new diagram. We can replace those three resistors by this one resistor here. So this one resistor is 220 ohms, right? And that we can also draw that diagram like this, right? We have the 100 ohm resistor here and a 120 ohm resistor here, right? So let's look at the diagram on the right. The current flowing through the 100 ohm resistor is the same as the current flowing through the 120 ohm resistor, because the 100 ohm resistor and the 120 ohm resistors are in series with each other. So because they are in series with each other, they have the same current flowing through them. Now, to actually calculate the current flowing through them, we look at the resistance, their combined resistance, right? So the equivalent resistance. So we look at the diagram on the left. So we have the 12 volts here. So the current flowing through the 220 ohm resistor is the same as the current flowing through the 100 ohm resistor, which is the same as the current flowing through the 120 ohm resistor. So in our equation here, R, we substitute this to be 220, not 100 ohms, right? And then we would get a value, and that value would be 6 over 110. And then, well, you could put that in your calculator and you will get a value, and that value, the unit would be in amps. Right, so that is part C. Now we will do part D, right? So a capacitor is an electrical device that has the ability to store electric charge. Define capacitance. So capacitance is the ratio of the stored charge to the potential difference across it, right? We can also write C is equal to Q over V. Calculate the capacitance of a parallel plate capacitor given that the distance between the plates is 10 centimeters, the area of each plate is 15 centimeters squared, and the voltage across the plates is 5 volts. So we have C is equal to epsilon naught A over D for a parallel plate capacitor, which would be equal to 8.85 by 10 to the negative 12 times A. Now the area of each plate is 15 centimeters, but we need centimeters squared, but we need to convert that to meters squared, right, to get our capacitance in farads. So 15 15 centimeters squared is equal to let's take an example just to show you the conversion, right? Let's say, for example, they did not tell us exactly what is the dimensions of the plates, but let's say it's 3 centimeters by 5 centimeters. This is equal to 15 centimeters squared, right? If we have this in meters now, this would be 0.03 meters times 0.05 meters. So this now is equal to 15 by 10 to the negative 4 meters. Right? So to convert centimeters to centimeters squared, this is meters squared, right? To convert centimeters squared to meters squared, we have to multiply by 10 to the minus 2 multiplied by 10 to the minus 2. So we would have to multiply the value by 10 to the minus 4. So A now would be 15 by 10 to the minus 4. And D, we have this in centimeters, so we convert that to meters. 10 centimeters is 0.1 meters. Right, so you could substitute this into your calculator. Let's just simplify it. 8.85 by 10 to the negative 15 times 15, and the unit is farads, right? So you could put that in your calculator and you will get a result. Now in this question, they gave us that the voltage across the plates is 5 volts. So that piece of information was not necessary to actually do the question, right? So some questions might be like that, where you might get information that you do not need to use to actually do the question. Right, now the last question in this paper. Sketchy magnetic field produced by 2 wires carrying current in opposite directions, that is into and out of the plane of the paper of the answer sheet. So let's say the wire on the left carries current into the page, and the wire on the right carries current out of the page. We know that the magnetic field produced by the wire, by each wire individually, would be in a circle around the wire, right? And the direction of the magnetic field we can find using the right hand rule. So this would be clockwise, and this one would be anti-clockwise. Now, as we know, the magnetic field produced by like, we know that like currents attract and unlike currents repel, right? So these are unlike currents because they're going in opposite directions. Therefore, they would repel each other. So because they would repel each other, the magnetic field we're no longer drawing as a circle, a perfect circle around the currents. We'll have to draw them being pushed away. So because they're being pushed away from each other, we'll draw them further apart on the outer ends and closer together in the space between the two currents. So we can draw them like this. I kind of have them a little too far apart, but basically it would be something like this, right? With less space in between them. Right, define Faraday's law. So Faraday's law states that the EMF induced in a conductor is directly proportional to the rate of change of magnetic flux experienced by that conductor. Right, now part B. A solenoid is constructed with 60 turns of copper wire around a cylinder of radius 2 centimeters and a length of 4 centimeters. A current of 5 amps flows through the solenoid. Determine the magnetic flux density at the center of the solenoid. So we know for a solenoid, B is equal to mu naught N I over L, right? Now we could substitute 4 pi by 10 to the negative 7 times 60 times 5 divided by L. Now L has to be in L has to be in meters, right? To have this as to put it in Teslas, L has to be in meters. So we would have to convert this. Now the question gave us the radius and the length. This L in this case has to be the length, right? So the length is 4 centimeters, which is 0.04 meters, right? The radius would be to calculate the cross-sectional area, but in this equation we have to use L as the length of the solenoid. So this would be equal to, you can cancel this 4, this would be equal to 1 here. So this would be pi by 10 to the negative 7 times 300 multiplied by 100. So this would be equal to 3 pi multiplied by 10 to the negative 3 Tesla. In part 2, calculate the magnetic flux at the center of the solenoid. So the magnetic flux at the center of the solenoid, you know, phi is equal to B times A times sine theta, right? But we know for a solenoid, the magnetic field is perpendicular to the coils, right? So therefore we could just write this as B times A. So this would be three pi by 10 to the minus 3 times A. Now the area, we have to use the cross-sectional area. So the cross-sectional area is equal to pi r squared, which is 3 pi by 10 to the negative 3 multiplied by pi multiplied by r squared. Now the radius is 2 centimeters, but to calculate phi in Webers, we need to have the radius in meters, right? So we convert this to 0.02 square, right? So this would be equal to 3 pi squared by 10 to the minus 3 multiplied by 4 by 10 to the negative 4. So now this would just be 1.2 pi squared multiplied by 10 to the negative 6 Webers. Right, in part 3 now, if soft iron is placed in the middle of the solenoid, will the magnetic field strength of the solenoid increase or decrease? Provide a brief explanation. So as we know, iron is a ferromagnetic material, right? And ferromagnetic materials are magnetized in the same direction as an external magnetic field, and they are strongly magnetized in that direction, right? And this is soft iron. So soft iron means that the iron is easily magnetized and easily demagnetized. Therefore, placing the soft iron in the middle of the solenoid, that soft iron is easily magnetized and also strongly magnetized in the same direction as the magnetic field of the solenoid. Therefore, when the solenoid is turned on, the iron is magnetized in the same direction, and it basically becomes a magnet as well. So therefore, the magnetic field strength of the solenoid increases by placing the soft iron core. In part C, determine the magnetic field strength at a distance of 10 centimeters from a wire of length 50 centimeters carrying a current of 2 amps. So to do that, we use the equation we need to determine the magnetic field strength. B is equal to mu naught I over 2 pi r. So mu naught is 4 pi by 10 to the negative 7. I is equal to 2 over 2 pi times the distance, right? So this distance, they asked for 10 centimeters. To get the field strength in Tesla, we need to convert this to meters. So this will be 0.1 meters. So this pi would cancel here, 2 would cancel here. So we would get 4 by 10 to the negative 6 Tesla, or we could write this as 4 microtesla, right? In this question, they told us the wire had a length of 50 centimeters. Now we need to look at our equation. We need to know which is the correct equation to use, so we don't mix it up, right? And so we don't necessarily need to use all the information given to us in the question. The wire is placed at an angle of 30 degrees to an external magnetic field of strength 0.06 Tesla. Determine the magnitude of the magnetic force on the wire. So we know magnetic force is equal to BIL sine theta. So in this part of the question, we need to use the information given previously. which is the length of the wire. Right? Because the length of the wire is going to be used in this question. So now we need to not confuse which value to put for B in this equation. So the magnetic force on the wire is produced by the external magnetic field, right? Not the magnetic field of the wire itself. So because if the magnetic field of the wire itself produces a force on itself, then that would make the wire start moving as soon as the current turned on, right? So the magnetic force is due to the external magnetic field. So in this question here, we have to use 0.06 as the value for B, which is the value of the magnitude of the external magnetic field. Then we multiply by the current and the length of the wire. So again, to get this force in newtons, we need to use the length of the wire in meters. So that would be 0.5 meters, right? And then they told us the wire is placed at an angle of 30 degrees. So we write multiplied by sine 30. So this is equal to, so 0.5 by 2 is equal to 1. So this would just be equal to 0.03 newtons, right? Because sine of 30 is equal to a half. So that is part C. Now part D, an electron enters a magnetic field of strength 0.5 Tesla with a velocity of 2 by 10 to the 8 meters per second. Determine the magnitude of the magnetic force on the electron. So in this equation, in this question, we use F is equal to BQV sine theta, right? The external magnetic field is 0.5 Tesla. The electric charge is 1.6 by 10 to the minus 19. Basically, the charge on the electron, which is the charge on the electron. The velocity is 2 by 10 to the 8 meters per second, right? And they did not give us the angle, so we assume that sine theta is equal to 90 degrees. Right, so this 0.5 could cancel with this 2. So what we would get here is 1.6 by 10 to the negative 11, and the unit would be newtons. Calculate the radius of curvature of the path of the electron in the magnetic field. So we know that this magnetic force acts perpendicular to the direction of motion of the electron. So because it acts perpendicular to the direction of motion of the electron, it acts like a centripetal force, right? So this magnetic force is equal to the centripetal force. So we can equate these two, the centripetal force and the magnetic force. And we can write BQV is equal to mv squared over r, right? the formula for the centripetal force is mv squared over r, right? Now this v cancels with the v squared, so now we can write r is equal to mv over bq. So this is equal to the mass of the electron is 9.11 times 10 to the negative 31 times the velocity is 2 by 10 to the 8 divided by the magnetic field strength is 0.5 Tesla times the charge of the electron is 1.6 by 10 to the negative 19. Right, now we could do some simplification. 9.11 so this is multiplied by 10 to the negative 31 minus 8 is 23. Two multiplied by 2 is 4 over 1.6 times 10 to the negative 19. Now this is 9.11 times 10 to the 23 minus 19 is 4. So you could write that as multiply by 4 over 1.6, which is equal to 9.11 by 10 to the negative 4, and 4 divided by 1.6 is equal to 2.5. Right, and then you could multiply this out yourself and you would get the answer in meters. Right, so that would be approximately 2 millimeters, right? Approximately 2 millimeters. That is the radius of curvature of the path of the electron. And well, yeah, so that is it for that exam paper. So do you have any questions?
Sir, essentially, is it possible you could verify that's everything you did in the class?
It is saying file block for security reasons.
Okay, I'll send it regularly.
Okay, send it by email. Just give me a minute.